Hey guys, hope you're doing well and thanks for watching today's video. So in the past we've talked about the idea of congruence. We went through some congruent shapes and what it means that they're congruent, what we can kind of derive from that. But now here we're going to get into the proof part of geometry. This is the part that a lot of people get a little bit scared of. It's the tough part of geometry. And so we're going to start off with methods of proving triangles are congruent. So again, I want to go back to kind of the basis of congruence. So when triangles are congruent, it means one triangle can be moved directly, coincide with the other triangle. This implies that all corresponding sides and angles are congruent. So now when it says corresponding sides and angles, we're going to talk about that again really quickly. So we have triangle, I'm going to call this one triangle RST, it looks like. That's not a good triangle. Let me make that a little better. And here we have triangle ABC. And we're proving they are congruent. So triangle ABC is congruent to triangle RST. Then what it says is that, let's label it here, ABC, RST. It's saying that, well, AB must be congruent to RS because they are corresponding. So corresponding means, again, it's the kind of the sides that could slide onto and be the exact same. So when you slide triangle RST to cover ABC, RS is going to be the new AB. So what it means that this is congruent to this. So we draw the same dashes. So the dashes kind of imply length, and if they have the same number of dashes, like 1, 2, 1, 2, that implies they are congruent. And so we can also imply that BC is congruent to ST, and lastly that ABC is congruent to RT. And we can do the same thing with angles. So we draw the angle symbols, and then we draw the lines through the angle symbols. So 1 here, 2 here, 3 here, and we'll do the same thing on our new shape RST. So 1 here, 2 here, 3 here, and that implies all the rules that we have listed down here. That each of these, so angle A, this one is congruent to angle R. Angle B is congruent to angle S. Angle C is congruent to angle T. And that's because corresponding sides and corresponding angles are congruent when triangles are congruent. This is really important for the proofs, and we're going to need to know that. So luckily, we do not have to prove all 6 of the facts that we just went over to prove triangles are congruent. There's certain combinations that are sufficient in doing so. These are things that you really have to memorize. And the good thing is they're pretty easy to memorize. First one is, so now I'm just going to talk about the combinations and what they mean. So first one, side, side, side. So if 3 triangles of a triangle are congruent to 3 sides of another triangle, the 2 triangles have to be congruent. So let me backtrack a little bit. So what we're doing is we're trying to, if I have 2 triangles, I'm trying to be able to prove that one triangle is congruent to another. So if I have triangle here and triangle here, there's no way I can say that they're congruent right now. I have to have some type of proof, some type of basis to go off of. Let me draw some triangles in here, and we'll use them as we go. So triangle here, triangle here. Okay, so side, side, side. It's saying if 3 sides of a congruent triangle are congruent, let me make these bigger, to 3 sides of another triangle, then the total triangles have to be congruent to one another. So what this means is that if I have, sorry, I'm not drawing very well. If I have this side is congruent to this side is congruent to this side, and this side is congruent to this side, the triangles are congruent. I have enough to prove that they are congruent, and that is the side, side, side. That's SSS, and you always call it by the name, so we'll call that one SSS. So we would say these triangles are congruent because of SSS. So that's our first combination. Second one is side, angle, side. So now let me erase these marks here. Let me erase our triangles. Now this one says if 2 sides and the included angle of one triangle are congruent to the corresponding parts of another triangle, the triangles are congruent. And we call this one SAS. So we got triangle 1, we have triangle 2. And then it says 2 sides and the included angle. So what does it mean by included angle? Well, that's the angle in between the 2 sides. So let's say I have this side, I have this side, and then I have this angle. What it's saying is that if I look at my other triangle and I have a side here that's the same length, I have an angle here that's the same as that angle, this one, and another side like that, so the included angle is the one in between the 2 sides that we have, that's this angle here, then the triangles have to be congruent. Notice that this is different than this situation here. Let me try to draw a little bit better. So triangle here and triangle here. What if I was given side, side, and angle? And I was given that this is, well, this is the same. So is this side angle side? Well, I have a side, I have an angle, I have a side, but this is not SAS. This is important that it's not SAS because it is not the included angle. It has to be the one in between the two sides. So in this case, it would have to be this one, but it isn't. So these are not congruent triangles because we don't know that the included angle is congruent. So it has to be the included angle like this one here. All right, so next example. Let's take a look at ASA. So this is angle side angle. I'm sure you're getting the hang of it now. So now we're going to have if two angles and the included side of one triangle. So again, we have this idea of included side. So that means if I have this angle here, what is the included side? Well, it has to be that one. And I get that that's congruent to these. Well, then that's enough to prove congruence. Again, let's look at an example where ASA would not be applied, but a lot of people would get tricked into thinking it is. Would be, well, this and maybe this side and this angle and this side and this angle. Well, this is not angle side angle because it would have to be this one. It's the included side in between two angles. So if I knew this one was congruent, I would have enough, but I don't right now, so that's not enough. So it has to be the included side. Okay, next one that we're going to talk about is AAS. That's the angle side. So again, two angles and the non-included side of one triangle are congruent to corresponding parts of another triangle. Let me show you what this one looks like. So here, and we're proving that they're congruent. So two angles and the included side, AAS. So two angles and the non-included side of one triangle. So let's think about what the non-included side means. So I have this angle, I have this angle. And the non-included side of one triangle are congruent to the corresponding parts of another, so here. So what is the non-included side? Well, that could be this one. That would be enough. It could be this one, that would be enough. So it means any side other than the one that we just talked about. So what we learned is that ASA is when it is the one that's inside, but AAS means that it's the non-included one. Because if you think about it, when you work with these, you have to go in the order of kind of what you're working with. So ASA means that we take the angle, we take the side in between, we take the next angle. AAS, we take the angle, so this one, we take the angle here, this one, and then we would take the side. So it can be any of the other sides. So that is also enough to prove that triangles are congruent, and that's AAS. And lastly, we have hypotenuse leg. So if the hypotenuse and leg of one right triangle are congruent to the corresponding parts of another right triangle, the right triangles are congruent. So as you can see, this is only applicable to right triangles. As you know, because it's a hypotenuse, the only triangles that have a hypotenuse are right triangles. So we're trying to prove they are congruent. The hypotenuse leg theorem says if the hypotenuse and the leg of one right triangle, so the hypotenuse are congruent, and the leg, so either one of the legs, that means the triangles are congruent. If you think about it, this doesn't even really need its own. It's kind of, well, I guess it does, but it's kind of similar to the AAS ones that we've talked about and side angle side even, because if you have a right triangle, it already shares one of the angles, but that's besides the point. So hypotenuse leg, basically, if you have a right triangle and you have them having the same hypotenuse length and one of the legs is the same, then they're going to be congruent. So it could also be this right here. We could have the hypotenuse being the same, and we could have the other legs being the same as well. And that would be enough to prove that they're congruent. So it can be either one of the legs, and that's the hypotenuse leg method for proving triangles are congruent. And all of these are really important as we go on, because we're going to talk about, in later videos, we're actually going to have examples of how we can prove that triangles are congruent using these rules. So I know that can probably be confusing right now. It's hard to explain without doing real examples, and we'll have that in a minute, just later on in the next video. So this is kind of just an introduction to all the theorems. Last one I want to talk about is the Cpctc, corresponding parts of congruent triangles are congruent. This is what we've said throughout the videos, through the last video and this one. And it says once we prove two triangles are congruent, the other parts that weren't in the combination will still be congruent. So what this means is that once I have like this triangle, and let's say I'm proving by SAS, let's say I'm given that this is congruent, and side angle side's got to be the included angle, so it's got to be that one. If I'm saying these are congruent, and once I have proven that they are congruent, Cpctc says that, okay, well, this must be the same as this angle has to be the same as this angle has to be the same. So 1, 2, 3, 1, 2, 1, 2. So it's saying that, well, this angle, this vertex angle has to be that, this angle has to be this, and this side has to be this side. Even though they weren't part of the congruent statement, even though they didn't help us prove that they were congruent, we still know they are congruent after we've proven the triangles are congruent, because that's the corresponding parts of congruent triangles are congruent. So hopefully this helps. I recommend that you just spend some time with these, read them a bunch of times, memorize them: SSS, SAS, ASA, AAS, and HL. HL is a less common one, but it's still important to know. So hopefully this makes sense. Let me know if you have any questions, and thanks for watching.